Hello friends, let's solve some simple problems on determining the Nyquist rate and the corresponding Nyquist interval based on the sampling theorem. The first problem is find the Nyquist rate and the Nyquist interval for the signal m of t equal to 5 cos 1000 pi t into cos 4000 pi t. Before we solve the problem, let us recall what we mean by Nyquist rate or what is the Nyquist rate. The Nyquist rate is given by 2 times W, where W is the maximum frequency of the signal and the corresponding Nyquist interval is given by 1 by 2W. Accordingly, for the given signal, using the formula for cos A cos B equal to half cos of A plus B into cos of A minus B, we can write down m of t as 5 by 2 into cos of A plus B, which will be 4000 plus 1000, that is 5000 pi t plus cos of 4000 minus 1000, that is 3000 pi t. Now we can see the frequencies present in this signal as follows. So 5 by 2 cos, we can compare it with the form cos 2 pi some frequency of 1t plus cos 2 pi some frequency of 2t. Now by comparison, it's clear that f1 is equal to 2500 hertz, and from here f2 is equal to 1500 or 1500 hertz. So what is W? The maximum frequency W is equal to max f1 comma f2, which is equal to 2500 hertz. Accordingly, the Nyquist rate 2W is equal to 2 times 2500 equal to 5000 samples per second, and similarly 1 by 2W is equal to 1 by 5000, that is 1 by 5 into 10 to the power minus 3, that is 0.2 milliseconds. Let us look at the next problem. Here m of t is given to be sine 200 pi t upon pi t. Now it is of the form of a sinc function. If we multiply and divide by 200, we get 200 sine 200 pi t upon 200 pi t. So now this is a sinc function, so we can write it down as 200 sinc 200 t, and it is of the form b sinc bt. Now we remember from our knowledge of Fourier transform that B sin bt has a Fourier transform of rect f by b. And how do we sketch rect f by b? Rect f by b is a rectangular pulse of height 1, width b, centered at the origin on the frequency scale. That means it is from minus b by 2 to plus b by 2, and the height of it is 1. Now accordingly, for our signal 200 sinc 200t, the corresponding Fourier transform would be, if we compare b is 200, so b by 2 is 100, minus b by 2 is minus 100. So the maximum frequency that is present here, b by 2, which we denote by w, so w is 100 hertz, and therefore the Nyquist rate, which is given by 2 times w, is equal to 2 into 100, which is equal to 200 hertz, or you can also call it 200 samples per second. And the Nyquist interval which is given by 1 by 2w is equal to 1 by 200 seconds, which is equal to 5 milliseconds. Let us look at the third problem, where the signal is the square of the previous signal. It's sine 200 pi t by pi t squared. Now here, as we saw in the previous problem, we can write this one as 200 sinc 200t, and this is the square of that. So basically this given signal is 200 sinc 200t times multiplied by 200 sinc 200. Now if we take the Fourier transform of the signal, that is, if we try to find out m of f, so m of f would be equal to the Fourier transform of this, Fourier transform of this, and their convolution. Multiplication becomes convolution. Multiplication in time becomes convolution in frequency. So here the Fourier transform we found out in the previous problem here. So it was rect f by b or rect f by 200. So rect f by 200 convolved with rect f by 200. And rect f by 200 is a rectangular pulse of height 1, width 200, centered at the origin on the frequency axis. So this pulse is being convolved with the same pulse. And we know from our knowledge of convolution that when two rectangular pulses of same width are convolved, the resultant signal is a triangular pulse. So the result is a triangular pulse on frequency axis. where the lower limit of this triangular pulse is equal to the sum of lower limits of the support, which is minus 100, minus 100, so minus 200. And similarly, the upper limit of this triangle, the extension of this triangular pulse on frequencies up to 100 plus 100, that is 200 hertz. And the height of this triangle is equal to the product of the amplitudes of the two rectangular pulses, which is 1 into 1 into the width of one of the pulses, because both are equal width. So 1 into 1 into this width 200, that is, it is equal to 200. We are familiar with these ideas from our knowledge of convolution. So basically what we get is a triangular pulse in frequency as the Fourier transform or the spectrum of the given signal. And once we know the spectrum, we know the maximum frequency content. So here W, this 200 is the maximum frequency, and therefore the Nyquist rate for this signal should be 2W, which is equal to 2 into 200, that is 400 hertz or 400 samples per second. And the Nyquist interval is 1 by 2W, which is 1 by 400 seconds, which is equal to 2.5 millisecond. So I hope these problems are clear. Thank you.